Hello, my name is Alexander Madrigal, and I will be giving an overview of Code 2, Weighted Random Sampling with Colors using a one-dimensional range tree. So the basic idea behind this is given a list of points along a number line, so only x values, each point will have a color, and given a query range, so an x min and an x max, within those points, we want to return a random point within that query range with probability according to the color of those points. So we can consider that if we have two colors, we have a color red with a weight of 1 and a color blue with a weight of 2. Within the query range, we will select a red point with probability 1 over 3 and a blue point with probability 2 over 3. So the way we will be doing this is we will be pre-processing the data in the tree and finding our random node through that way. So within our range tree, we're going to store, each parent is going to store the child node with the greatest key, and that key will be dependent on the color's weight. We are going to find all the canonical nodes within the query range and select the canonical node with the greatest key, and that canonical node will store one of the child nodes with the greatest key. And that node it is storing will be the node you will return, which is our weighted random node dependent on color. One thing to consider is that for the same query range, this program will always return the same leaf node. So for our node class, we now, instead of just an x value, we now have an x value and a color. And instead of a weight, we have left and right, but instead of a weight, we now have a key and max node. Then for the query range is the same. We have an x minimum and x maximum value. And then get x is still the same. It is getting our x value, which we are using for sorting. So for build range tree, we're taking a list of points as well as a dictionary of colors linked with weights. So our dictionary, we will be able to look up a color, which is a string, and it will give us back a weight. So for instance, if red has a weight of 1, if we look up red in our dictionary, it will return 1. So in the case where there's only 1 or less points, we will create a new node at that point and set a key to a random variable 0 to 1 to the power of 1 divided by the weight of that color, simply by looking up from the dictionary that node's color, which will then return that color's weight. Then, since it is the only node in the list, the max node is simply itself, which, remember again, the max node stores the node from its children with the greatest key. And since it doesn't have any children, it is thus itself. So for the recursive case, where p has more than one point, it is the same, where we find the median node, split p into two halves, the left half and the right half, along the median node. Then we set our current node to that median node, and then recursively make the left node build the range tree on the left side, and then the right node build range tree on the right side. Now the one difference is where we are going to assign these key and max node. So between the two children, we want to assign V's key and max node to whichever child has the greatest key. So if V's key is greater than V right's key, we will make V's key V left's key, and since V left has the greatest key, we will set v's max node equal to v left max node. And remember that when v left is a leaf, v left max node is simply itself. And in the else case, where v left key is less than v right, so the right key is greater, we simply make our v's key equal to v right key and v's max node equal to v right because v right has the greatest max key, or the v right's max node. Now we have find split node and find canonical set. These are exactly the same as the previous code we did, uniform random sampling using one-dimensional range tree. So if you'd like to see how these two work, please look at that video. But simply we find the split node, and then using the split node, we can build the canonical set, which will give us the list of all canonical nodes. Now, given a list of all canonical nodes, we can make the function weighted random color node, which will return the node with the greatest key stored within the canonical nodes. So what we do is we simply set Cmax to the initial canonical node in the set and iterate through the entire canonical set and look that if our current canonical node's key is greater than Cmax's key, we set Cmax equal to that canonical node. So after this ends, Cmax will be the canonical node with the greatest key. And then we simply return Cmax's max node, which if you remember will be the leaf at that canonical node which has the greatest key. Now we have two functions to prove correctness. We have prove uniform random and prove weighted colors. Prove uniform random is the same one as in the previous code, and the reason we have this here is because consider that if in our list of points we only have one color, so for instance they are all red, this problem essentially turns exactly into the uniform random sampling problem, where each node has an equal chance to be selected. And more importantly, we have the prove weighted colors, where we arbitrarily decided that we only have 3 colors, and we return a frequency list giving us the percentage of red, blue, and yellow nodes selected over multiple iterations of running this program. Now for how the code, we built a database, a list of points, simply again from 0 to 999. We have a color dictionary with 3 colors, where red has a weight of 1, blue has a weight of 3, and yellow has a weight of 6. So this will be chosen with probability 1 over 10, 3 over 10, and 6 over 10, since they all add up to 10. And we set each point to a random color. Now, we set num iterations to 1,000 times, and our query range we defined as 200 to 300. We built the range tree, we found the canonical set, and as an example, we had a random node set equal to weighted random color node from the canonical set. Consider that if we, for instance, call weighted random node again, it will return the same exact value because the canonical set is not changing, because the query range is not changing. So consider that if the query range is not changing, the canonical set will not change. It will always return the same value. So the only way to get a different value is to change the query range or to rebuild the range tree, which is what we were required to do for prove weighted colors. As you can see, we had to rebuild the range tree, which is inefficient. And that is one of the drawbacks of this program. So I will show an example of returning a random node and then prove weighted colors. So as you can see, it gave us a random node from range 200 to 300, and it gave us the probabilities of each color being selected. So as you can see, it's slightly deviated from the 10%, 30%, and 60%, but it is very close.